Apache Hadoop ecosystem, expansion of what I drew before. There is the Hadoop distributed file system, HDFS, on top of which there is a MapReduce engine. This is the environment we were talking about, which provides us all the underlying parallel distributed functionality. Both of them run on something called the Hadoop Common, which is a common set of libraries that are useful both for HDFS and MapReduce. Typically, a user doesn't directly utilize or meddle with what is in Hadoop Common. You may inherit a class from there because you know what classes are there in Hadoop Common, but typically you would work on top of MapReduce. All the brown components here are the core components of Hadoop, and the blue ones are the ecosystem components. Some of the ecosystem components may work directly on the HDFS, and some of them work on top of MapReduce. Okay? MapReduce, what I mean to say is, when you write a Hive script, okay, Hive provides a query language like SQL, which is called HQL. This database query language, when you write in HQL, let's say you would say select star from a particular table, that gets translated as a MapReduce program. And the MapReduce program executes on top of Hadoop. That's how it runs. So Hive as an ecosystem component sits on top of MapReduce. Whereas HBase as an ecosystem component sits on top of HDFS directly. So it could be either way. Sit on MapReduce or sit on HDFS. And some components we have listed here. I won't go into the details of them at this time. And it's possible that some ecosystem components use other ecosystem components, because each of these are independent efforts. HBase uses Zookeeper. And let's get a view of MapReduce, 10,000 meter view of MapReduce. We said that when data goes in, HDFS chops it up into blocks. These are those blocks, split 0 to split 4. Now, for simplicity, we are not showing the data replication here. It exists inside HDFS. What happens in MapReduce is mapper tasks are running on individual data nodes. In this case, split 0 and split 3 are sitting on the same physical machine. Split 0 and split 3. Hence, both of them are being handled by the same mapper job. Likewise, split 1 and split 4 are on one machine, and split 2 is on a separate machine. So, a mapper job runs and produces some output. This output is being produced on that local data node, right? Local physical machine. It is being produced. It is on that hard drive, on that intermediate storage. And there is a stage called sorting and shuffling that happens after the map. Sorting and shuffling essentially collects the output from individual nodes, brings all of it together, sorts it, shuffles it. That is the data movement that happens this area. The entire communication between different nodes is being restricted to this time. Once data sort of gets exchanged at this point, from here or here, there is no interaction happening between different worker nodes. Near the reducer node. So it could be on a separate machine, or it could be on the same node that reducer is running. Once you have this sorted data, it goes into the reducer. When we say map and reduce, these are nothing but individual programs, individual Java objects. For those of you who are familiar with object-oriented programming, map is an object, reduce is an object. Okay. Once you finish the reduction, the output is produced. This is the output of the first reducer, so it's called part 0. This is the output of, in this case there are two reducers, part 0 and part 1. The number of reducers will determine the number of output files produced. It is the responsibility of you or the client to look at both the outputs. The Hadoop system doesn't combine these and give you a single output. Whatever comes out of the reducer is what you get. There is no other combining step after.
Or write a reducer of reducers.
Sorry?
Or is it common to write a reducer of reducers?
There is only one reducer. So you may write another MapReduce cycle where they get combined in case that is essential.
Or in the reducer, it's a program, so
you can do whatever you want. Sometimes you write multiple reducers because single reducer would have to handle a lot of data. You see here, you have split into 5 splits and you are running mappers on them. But reducer, if you have only had a single reducer, then it has to handle the entire data. So typically reducers are more burdened in terms of the amount of data they need to process than mappers. So when your data size is very, very large, you will do multiple reducers. Hence you will get multiple parts of the output. It's not a major inconvenience to get multiple parts of the output. Typically, I mean, your reducers may be, for example, a log processing application. You are writing a log processing application. My Sunday logs, Monday logs, Tuesday logs. I will write one reducer for each day. So that will sort of split the data between 7 reducers and reduce the load of the system. Whereas if I had sent everything to one, then my reducer may become my bottleneck. The things in yellow here, the yellow pieces, are the ones that are on HDFS. Okay, they are sitting on the file system. The things in white, which are the boxes in the middle, are sitting on local storage of the nodes. Yeah. So let's going back to our correcting papers example. Each of you have a set of papers. You may have a notebook where you are making some notes. That intermediate data while you are processing is your internal storage. You don't share it with the rest of the network. And final results also, you would finish doing the papers and you would keep it with you. It is in your internal storage. You don't communicate the result to anybody. The worker node does not have the responsibility to communicate back. The mapper, so the job tracker, which is the coordinator, the master, after work is given to the worker nodes, the master keeps tracking each worker node. There is something called the heartbeat signal. So the worker node keeps sending back a heartbeat signal every 2 minutes. Yeah, I'm just getting done. Yeah, I'm almost finished. I'm done. Okay, each of you would keep sending that heartbeat signal. Once the heartbeat signal, once the master knows that a particular worker node has completed, then it is the master's responsibility to collect the data from there, pass it on to the second stage of processing of that paper. Maybe there's a reducer sitting somewhere who needs to consolidate marks and make a mark sheet. All the math mark sheets are with one person, all the science mark sheets are with one person. So it's the master's job to collect all of that and give the papers to the persons that are accumulating the results. So the data movement at that stage is between the local storage of one node to the local storage of another node, but done through remote procedure calls by the master. Then whoever is accumulating finishes making the sheet of marks and brings it and puts it on the central table. So it is the reducer's responsibility to output the results to HDFS. HDFS is the shared single namespace, shared between all the machines. Whereas local storage is that white box.